A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headache.
If you're building anything with AI, check them out. Modal.com. You know, Herman, I was looking at some integration code yesterday. A developer was trying to send a simple push notification, and they were staring at about 47 lines of raw HTTP headers, JSON formatting, and manual authentication logic. It looked like they were trying to build a rocket ship just across the street. Then they swapped it for an SDK, and suddenly it was 3 lines of code. It really highlights the gap between having a door and having the key to that door.
That is a perfect way to frame it, Corn. And by the way, I am Herman Poppleberry, and today's prompt from Daniel is actually taking us right into that gap. He wants us to dig into SDKs, software development kits, what they are, why companies sink millions of dollars into building them, and why a developer should care about using them over a raw API. It is a fundamental architectural choice that people often take for granted. Oh, and before we dive into the deep end, I should mention that today's episode is powered by Google Gemini 3 Flash.
It is funny how we use these terms interchangeably sometimes, but they are very different beasts. Most people know what an API is, the application programming interface. It is the contract, right? It says, if you send me this specific payload to this specific URL, I will give you back this data. But Daniel is asking about the SDK. So, Herman, for the folks who might be a bit fuzzy on the distinction, what is the actual physical, or I guess digital composition of an SDK versus just the API?
Think of the API as the menu at a restaurant. It tells you what is available and how to ask for it. The SDK is the entire kitchen, the chef, and the delivery driver all wrapped into one box. Technically speaking, an SDK is a collection of tools. It usually includes libraries, which are the pre-written code that speaks to the API, but it also includes documentation, code samples, maybe some debugging tools, and sometimes even a local emulator. An API is just the interface. The SDK is the implementation of a workflow around that interface.
So if the API is the what, the SDK is the how. I like that. But I see this all the time in the open source world developers who pride themselves on not using SDKs. They call them bloated. They say, I can just write a fetch request to the endpoint myself. Why do I need your 3 megabyte library? And honestly, sometimes they have a point. If I am just hitting one endpoint once, is an SDK overkill?
It can be, but that is a very surface level way to look at it. When you use a raw API, you are responsible for everything. You have to handle the authentication headers, which in 2026 with OAuth 3 and complex token rotations is not trivial. You have to handle the serialization of data. You have to handle error codes. What happens if the server returns a 503? Do you have an exponential backoff strategy ready to go? Most developers writing a raw fetch request do not. They just write a try-catch block and hope for the best.
Right, and then their app crashes the moment there is a flicker in the network. I guess that leads us into the why. Why are companies like Stripe, AWS, or Twilio so obsessed with making sure you use their SDK? They are not just doing it out of the goodness of their hearts. There is a massive strategic play here.
There is a huge strategic moat involved. If I am a company like Twilio, my product is only as good as the developer's ability to use it. If it takes a developer a week to figure out how to format an SMS request across different international carriers using raw protocols, they might give up and go to a competitor. But if I give them an SDK that handles all those carrier quirks and reduces the integration time from days to literally hours, I have won. Low friction equals high adoption.
It is the ultimate developer experience play, but it is also about lock-in, isn't it? Once I have integrated the Stripe SDK across my entire backend, switching to another provider isn't just a matter of changing a URL bridge. I have to rip out an entire library and rethink my data models.
It definitely creates a higher switching cost, but I think we should talk about the hidden costs of raw API usage that the SDK hides from you. Take something like the Stripe SDK. One of the biggest things it does is handle PCI compliance details at the code level. It ensures that sensitive credit card data never actually touches your server by using its own internal mechanisms. If you try to do that with a raw API, you are suddenly on the hook for a lot more security auditing. The SDK is essentially a shield.
That is a great point. It is not just a convenience wrapper, it is a compliance and security wrapper. I remember seeing a case study about Twilio specifically. They had these massive issues early on where developers didn't understand how to handle the different SMS protocols for, say, a carrier in Brazil versus one in the United Kingdom. The SDK abstracted all of that away. The developer just calls a send message function, and the SDK's internal logic handles the mess.
Wait, I promised I wouldn't say that word. You are right, and it goes deeper into the secret zero problem we often see in security. SDKs can often integrate directly with secret management systems. Instead of you having to manually fetch an API key and pass it into a header where it might get logged or leaked, the SDK can talk directly to your environment's identity provider. It is a much more robust way to handle non-human identity.
Let's talk about the performance side of this. Some people argue that SDKs add latency because of the abstraction layers, but I have seen cases where the opposite is true. I was reading about a startup that was using the OpenAI API directly for their agentic workflows. They were hitting rate limits constantly, and their token usage was through the roof. They switched to the official SDK, and their token waste dropped by 15%.
That is because a well-built SDK has smart caching and session management built in. If you are making multiple calls to an LLM, the SDK might be reusing the underlying TCP connection, or it might be caching certain system prompts that don't change. If you are doing that yourself with raw HTTP calls, you are likely opening and closing connections constantly, which adds massive overhead.
And don't forget retry logic. This is where most raw API integrations fail. A developer writes a script, it works on their local machine. They deploy it, and then the first time there is a network hiccup. The whole thing falls over because they didn't implement a jittered exponential backoff. The SDK gives you that for free. It is like having a tiny, very experienced engineer sitting inside your codebase saying, "Hey, the server is busy, let's wait 200 milliseconds and try again."
And it is not just about retries, it is about the second-order effects of that stability. When your integrations are stable, your time to market for new features accelerates. You aren't spending 50% of your sprint fixing broken integrations, you're building new stuff. This is why companies invest so heavily in them. They want their service to be the most invisible, reliable part of your stack.
I want to push back a little on the moat idea. If I am a savvy developer, shouldn't I be worried about being too dependent on a single vendor's SDK? We have seen this with cloud providers. If you use the AWS SDK for everything, moving to Azure is a nightmare because even the way you handle errors is defined by the AWS library's types.
That is a real risk. It is the vendor SDK moat. But there is a middle ground. Many sophisticated teams use what I call a service wrapper or a hexagonal architecture. They use the vendor SDK, but they wrap it in their own internal interface. So, if they ever need to switch, they only have to change the code inside that wrapper. But even then, you are still getting the benefit of the SDK's internal optimizations.
It is basically about where you draw the line of abstraction. If you use the raw API, you are drawing the line at the network boundary. If you use the SDK, you are drawing it inside your application logic. I think for most modern applications, drawing it inside the logic is actually safer because the network is the most unreliable part of the system.
Let's look at another example, the AWS SDK versus the raw S3 API. Have you ever looked at the raw S3 API documentation? It is a labyrinth of XML-based headers and specific signing algorithms for requests. Writing a raw PUT request to S3 is an afternoon-long project. With the SDK, it is a single function call. And more importantly, the SDK handles region failover. If the US East 1 region is having a bad day, the SDK can be configured to automatically route your request to another region. Doing that manually with raw APIs would require a massive amount of infrastructure code.
And that is code you have to maintain. That is the thing people forget. Code is a liability, not an asset. Every line of raw API handling you write is a line you have to debug, update when the API version changes, and document for the next person. The SDK offloads that maintenance to the vendor. When Stripe updates their API from version 2024 to 2025, they update the SDK. You just bump the version in your package manager, and 80% of the work is done.
That is the API tax we have talked about before. Building it twice, once for the functionality and once for the plumbing. The SDK eliminates the plumbing tax. And in the world of AI agents, this is becoming even more critical. We are seeing the rise of things like the Model Context Protocol, or MCP, where the goal is to make these integrations even more standardized. But even there, you are going to want an SDK to handle the handshake between the agent and the tool.
You mentioned AI agents, and that brings up an interesting point. As we move into 2026, we are seeing more agent-first SDKs. These aren't just for human developers to call, they're designed to be easily read and invoked by an LLM. They have better metadata, clearer function names, and built-in descriptions that tell an agent exactly what the tool does.
It is a shift from code for humans to code for systems. And if you are using a raw API, you have to provide all that context to the agent yourself. You have to write the system prompt that explains how the API works. An agent-optimized SDK basically comes with its own instruction manual that the agent can digest instantly.
So, we have established that SDKs are faster, safer, and often more performant. But let's talk about the downsides for a second. Bloat is real. I have seen some SDKs that pull in 50 dependencies. Suddenly, your small web app has a 20 megabyte bundle size because you wanted to add one login with Google button.
That is a huge problem, especially in the JavaScript ecosystem. It is what I call dependency soup. A poorly designed SDK can introduce security vulnerabilities through its own third-party dependencies. This is why when you are evaluating an SDK, you shouldn't just look at the features. You should look at the dependency tree. Is it tree shakeable? Can you import just the parts you need?
Right. If I only need the send function, I shouldn't have to import the entire analytics and UI component suite that comes with the SDK. Some of the better ones now are very modular. You see this with the newer versions of the AWS SDK for JavaScript. You can install just the S3 client instead of the whole AWS beast.
That is the hallmark of a mature SDK. And that brings up a good practical takeaway for the listeners. When you are choosing between an SDK and a raw API, or between two different vendors, look at the SDK's release frequency. If they haven't updated the library in 6 months, but the API has had 3 new versions, that is a massive red flag. It means the SDK is an afterthought for that company.
Also, look at the Issues tab on GitHub. If there are 300 open bugs about memory leaks or unhandled exceptions, you might actually be better off writing your own lightweight wrapper for the raw API. An SDK is only as good as the team maintaining it.
And don't forget the documentation. A great SDK is useless if the documentation is just a generated list of function names with no context. I want to see recipes. Show me how to use the SDK to solve a specific problem, like how to implement a subscription billing cycle with a free trial. If the SDK documentation is just a technical spec, it hasn't actually lowered the friction.
It is funny, we talk about these as kits, but often they feel more like frameworks. They want to dictate how you structure your entire application. That is where I get a little cheeky with it. I will see an SDK that wants to manage my entire state or tell me which database to use. And I'm like, whoa there, buddy, I just wanted to send a tweet. Relax.
That is the framework creep. Some companies try to turn their SDK into a platform. They want to be the center of your universe. As a developer, you have to be disciplined. Use the SDK for what it is good at, the plumbing, but don't let it dictate your application's architecture. Keep your business logic pure and your integrations at the edges.
So, what is the moment here? I think it is realizing that an SDK is essentially a productized best practice. When you use the Stripe SDK, you are just using code. You are using the collective wisdom of hundreds of engineers who have spent a decade figuring out the best way to handle payments. You are buying or using for free their mistakes so you don't have to make them.
I love that. Productized best practice. It is the same with the OpenAI SDK. They have figured out the optimal way to stream chunks of text back to a browser so it feels smooth to the user. You could spend a week figuring out server-sent events and buffer management, or you could just use the stream parameter in their SDK. Why reinvent the wheel when the wheel is already balanced and tires are pumped?
Dang it, you almost got me to say it. But let's look at the future. We are starting to see AI-generated SDKs, tools that can look at an API's open API specification and generate a full idiomatic SDK in any language instantly. Does that change the moat strategy for companies?
It lowers the barrier to entry for smaller companies to provide a great developer experience. If you can generate a high-quality SDK with one click, you don't need a dedicated developer relations team of 20 people. But the value then shifts from just having an SDK to having a hand-tuned SDK. An AI can generate the boilerplate, but it might not understand the subtle nuances of how a specific language handles concurrency or memory management.
True. A generated SDK for Rust is going to look very different from a generated SDK for Python if you want them to feel native to those developers. A Python developer wants something that feels Pythonic, easy to read, lots of decorators, maybe some async await. A Rust developer wants strict type safety and clear ownership rules. An AI might get 80% there, but that last 20% is where the real delight lives.
And that delight is what leads to adoption. This is why I think the role of the SDK is actually going to become more important, not less. As the world becomes more automated and we have more non-human entities interacting with these services, we need these middlemen to ensure the communication is efficient and secure.
It is like we are building a more robust layer of digital social norms. The SDK is the etiquette of the internet. It tells you how to behave so you don't overwhelm the server, and it tells the server how to treat you so you don't get frustrated.
That is a very sloth-like philosophical take, Corn. I like it. But let's bring it back to the practical. If you are a developer listening to this and you are starting a new project today, what is your rubric? When do you reach for the SDK and when do you go raw?
My rubric is simple. Is this a core part of my business or just a side quest? If I'm building a payment app, I'm using the payment provider's SDK because I want their security and their best practices. If I'm just hitting a random weather API once a day to show a little icon in the corner of my app, I will just use a raw fetch. I don't need a 5 MB weather SDK for that.
I would add a second rule. Look at the complexity of the authentication. If it is a simple API key in the header, raw is fine. If it involves HMAC signatures, token rotation, or complex OAuth flows, use the SDK. Life is too short to debug signature mismatches in 2026.
Oh man, signature mismatches are the seventh circle of developer hell. I have spent more hours of my life than I care to admit staring at two strings that look identical but have one invisible character difference that breaks the whole crypto hash. If an SDK can take that pain away, I will give it all the disk space it wants.
And the third rule for me is observability. Most modern SDKs have built-in hooks for things like OpenTelemetry. They can automatically report how long a request took, whether it failed, and what the error was to your monitoring dashboard. If you go raw, you have to instrument all of that yourself. And let's be honest, most of us will get around to that later and then never do.
Guilty as charged. It is the instrumentation debt that kills you when you are trying to scale. Okay, so we have covered the what, the why, and the how. We have talked about the strategic moats, the performance benefits, the security shields, and the productized best practices. What are the big takeaways for Daniel and the rest of the listeners?
Takeaway number 1. Evaluate the SDK as a product in itself. Don't just look at the service it connects to. Look at the documentation, the community support, and the update frequency. A bad SDK can be a bigger liability than no SDK at all.
Takeaway number 2. Use SDKs for your heavy lifting. Payments, complex cloud storage, AI model interactions. These are areas where the API tax is highest and the risk of getting it wrong is greatest. Let the experts handle the plumbing.
And takeaway number 3. Be mindful of bloat. If you are building for the web especially, check if the SDK is modular. Don't let a convenience library destroy your page load times.
And I will add a fourth one. Always wrap your external dependencies. Even if you use the most amazing SDK in the world, put it behind a simple interface in your own code. It gives you the power to switch or mock it for testing without rewriting your entire application. It is about maintaining your sovereignty while using the best tools available.
Sovereign development. I like the sound of that. It is a balance between leverage and independence.
It really is. So, looking ahead, I am curious if we will see a world where the SDK becomes a standard part of the operating system. Like, instead of every app having its own AWS library, the OS provides a standardized way to talk to these big services. We are already seeing hints of that with how mobile OSs handle things like biometrics or location services.
That would be the ultimate abstraction. But then you run into the problem of the OS vendor becoming the ultimate gatekeeper. If Apple or Google decides how you talk to an AI, they control the flow of information. I think the portable SDK that you can drop into any environment is a safer bet for a decentralized web.
True, and with WebAssembly, or WASM, we are seeing the ability to run these SDKs at near-native speeds in the browser or on the edge. That is going to change the performance argument entirely. You won't have to choose between fast and easy anymore. You can have both.
That is the dream, isn't it? Writing code that is as easy as a 3-line script, but as robust as a bank's backend. We are getting closer every day.
We really are. Well, Herman, I think we have thoroughly dissected the SDK. From the strategic moats of 2026 to the hidden costs of raw API plumbing, it is a lot more than just some helper functions.
It is the infrastructure of the modern developer's mind. And a big thanks to our producer, Hilbert Flumingtop, for keeping the wheels turning on this ship.
And of course, big thanks to Modal for providing the GPU credits that power this show. They are the ones making sure we have the horsepower to dive this deep every week.
This has been My Weird Prompts. If you are finding these deep dives useful, leave us a review on Apple Podcasts or Spotify. It actually makes a huge difference in helping other curious developers find the show.
Or just tell a friend. Word of mouth is the original SDK. It is low friction and very high impact.
Until next time.
Catch you later. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.